Problem number 1. It says find the critical points of each function, of this function here, and list them as ordered pairs. Don't worry what type of critical point they may be. I'm not worried whether it's a maximum, minimum, or a point of inflection. But here's how we're going to do it. What's going to happen, if you think about this, we have this line, and this line is coming in here, and it's doing something. Let me draw that again. That's pretty poor. That's all right. It's coming in here, and it's doing this little hump right here and going back up. Well, where's this guy? We want to know where the critical point's going to be. Well, right here is going to be where it sort of came down and it hit, started going up. So this would have been a minimum. Went back up and then started coming back down. Right here is going to be your maximum. Let's talk about those at first. What's going to happen? How can I find that point? Well, notice at that point, the tangent line right here is going to have a slope of nothing. It's going to have a slope of 0. Okay, the big 0. This guy here, that tangent line is also going to have a slope of 0. So we're looking for those points. So all I need to do is the tangent line will have a slope of 0 at this maximum minimum point. Well, remember that the derivative of an equation tells you the slope of the tangent line at any particular point. So all I got to do is take the derivative and set this equal to 0, and I can find that ordered pair there and there. So let's do that first. So the first thing I'm going to do is let's take the derivative. I bring my 3 down, so that's 3x squared. I bring the 2 down, so that's 6. And then again, the exponents always drop by a power, 6x, plus then that 2 just disappears. Now, this derivative tells you the slope at any particular point on this line right here. Well, you and I already know the slope is 0, so all we got to do is figure out, hey, when is this 3x squared plus 6x going to be equal to 0? That'll tell us where that point and that point are. So what I do is I go ahead and set it equal to 0. Notice that what you can do, now a lot of us are going to want to put the 0 over here because it's just easier for us to see, and that's fine, no big deal. What I'm going to do first, I'm going to factor out. I notice they both share a 3 and they both have an x. That'll leave behind an x plus 2 equaling 0. Well, that means either 3x is 0 or the x plus 2 is 0. So 3x is 0 or the x plus 2 has to be 0. Solving this, I get x is 0. Subtract 2, you're going to get negative 2. Here are 2 of your x values. Here's your 0, here's your negative 2. Well, if I plug 0 back into the original equation, I can tell where that is. I plug 0 in there, I'm going to get 2. That means this guy right there is at 0, 2. For negative 2, and again, you don't have to worry about the graph. We just simply take the derivative, set the derivative equal to 0, and it's going to tell us our 2 x values. We plug those x values back into the original equation to find the height, the y value. So now I'm going to plug negative 2 in here. And when I plug negative 2 in here, that's going to be negative 8 plus 12 is 4 plus 2. I'm going to get the ordered pair negative 2, height of 6. So this guy right here was at negative 2, height of 6, which again, we're not worried about. We know, hey, here's a critical point, here's a critical point. And again, you don't know what the graph looks like, so I'm not worried whether you know it's a maximum or minimum. Just I wanted you to figure, hey, here's a critical point, here's a critical point. That's all I wanted. Now, don't forget there's also that point of inflection. The point of inflection, well, the way we get that, here was the first derivative. All we do is we take the second derivative. So we take the derivative of this derivative. Well, when I bring my 2 down, that's going to make it 6x plus 6. And then we do the same thing. Set this second derivative equal to 0 and solve it. Move your 6 over. Or you could factor out here. But we'll just move our 6 over, divide by 6, we're going to get negative 1. So I know that there's going to be a critical point, which I do know is going to be the point of inflection, at negative 1 comma, well, what's the height? Well, I plug negative 1 back into this original equation to figure it out. Well, negative 1 to the third is negative 1. Negative 1 squared is 1 plus 3, so that's then plus 3 plus the 2, 5, take away 1, I got 4. There is my third critical point. So problem 1, again, it's not that hard. It just takes a little bit of time. It's like reading a novel. You can't finish it in 20 minutes. You got to spend a little time on it. Same with this when we're trying to find the critical points. Not difficult to do. You just got to spend a little bit of time and a little bit of paper to calculate where they are.